both working for the National Research Council in Rome, and they're presenting really, really timely and important work on innovation and sustainability, but with a really good, strong focus on a very understudied area within that, and that is the loss of biodiversity. And we're really burning to hear more about this. So therefore, without further ado, I'll hand over to our presenters. We have two discussants following on the presentation, I should say. Daniele, who is a professor at Birkbeck, you know, and a member of CIMR, who also has two hats and also has a hat working at the National Research Council in Rome, and of course, our director of the Centre for Innovation Management Research, Helen. And after the discussions finished, I'll take questions from the audience. Thank you.
You can start.
Yes, you can start.
Thank you, Helen and Marion, for the invitation. This is the second time for me here at Birkbeck, and it is a great pleasure to meet all of you again. Just few minutes. Let me just few minutes for introducing the general framework in which the research activities that Viviana present is present. The first question. First question is why biodiversity? Biodiversity plays a crucial role in addressing the grand challenges concerning climate change and global warming. Climate change and biodiversity are deeply connected, and each affects the other. For example, human activities that produce biodiversity loss increase carbon emission and affect the global warming. So protecting biodiversity is not necessary just for ecological reasons, but the biodiversity plays a crucial role in addressing climate action, climate measure, climate policies. This is the distribution of protected areas in Italy. Nearly 46% of protected areas in Italy are at risk of conservation. So, for this reason, the Italian government, through the recovery plan, founded a specific project, the National Biodiversity Future Center. The center is a network of university, public research institution, and private company. And the total budget of the project is about 350 million euros. And more than 1,000 researchers are spread all over Italy, are involved in the project. And the main goals of the center is to promote research concerning monitoring, conservation, restoration of biodiversity. And there are some tasks in the project concerning the how public policies could address biodiversity outcomes, and we are involved in these tasks. The second question concerns why a research team of the with economic, juridical, social skills is involved in biodiversity issues. The reason is because biodiversity, we consider biodiversity an economic asset. In according to Stern and Stiglitz, the promotion of research activities for addressing the grand challenges concerning climate change and biodiversity loss could be a useful drivers for technological innovation and for the economic growth. So Stern and Stiglitz argue that for addressing these grand challenges, we need a mix of different policy measures, and science, technological innovation policies play a crucial role in this framework. So our focus is how this kind of policies, science, technology, innovation policies, could address biodiversity outcomes. We are involved in two specific research activities. The first concern the analysis of public procurement for innovation at the European level. The public procurement for innovation is the main tool for demand-side public policies. And the last year, I have presented here the preliminary findings about this work. Today, we present the second task of our research activities concerning the methodological challenges for identifying and monitoring technology that could address biodiversity loss. And this is through patent analysis. And this is the core of the presentation of Viviana. And so I leave the floor to Viviana for her presentation.
Thank you, Fabrizio. So basically, in a nutshell, what Fabrizio said is that biodiversity, it's a challenge, it's a huge challenge, and it's very likely to become one of the grand challenges of our time, mostly likely to replace environmental challenge, etc. Technology, it's a very important driver in order to solve the biodiversity issues. But what are those technologies which could be relevant for biodiversity? In general, we can distinguish two broad categories. One is technologies for monitoring biodiversity loss, which include all the technologies that basically are able to collect data. And we distinguish remote sensing, so any technology that can collect data from remote. So, and we include in these categories, for instance, also satellite, which collect data from the space. And also proximal sensing, which are sensors and technologies which can collect specifically data on very specific assets, for instance, plants or soils, or even drones, which is a technology developed for other purpose, but it's typically used to collect data, for instance, about the state of the soil. A second category of technologies for biodiversity concern the restoration activity, so all the technologies that could be used to restore any biodiversity loss. And in this broad category, I'm really simplifying, but we can distinguish the nature-based solutions, so they are solutions based on biological pillars, I would say. So the idea is, for instance, to restore the reef under the sea with organic compounds, organic biopolymers, but constructed with 3D printers by the human activities, but also genetic gene editing, or all the DNA-based technologies, for instance, that are able to change the architecture of an organism. So this is a very broad framework and some context to be able to understand what are we going to talk. So technologies are very important, but the thing is that so far we lack of specific technological indicators to measure and to assess technologies for biodiversity. Specifically, we don't have specific classifications to identify patents concerning biodiversity. We need to mention that the only two classifications currently available which enable to identify technologies, specifically patents, to address biodiversity challenge are the two I'm representing in these slides, which are the YO2 climate change mitigation technologies, which was developed by the cooperation patent by the CPC, And it's basically a classification which assign a label which begin with the Y letter to all the patents and concerning technologies which fall into one of those areas. So energy systems, greenhouse gas emission capture and storage, emission reduction, waste and waste ever, etc. A second sort of classification is the WIPO IPC Green Inventory, which it's actually not a new classification per se like the YO2, but it's more like a selection of specific IPC classes in which we would be very likely to find technologies concerning alternative, for instance, alternative energy production, energy conservation, green transportation, waste treatment, etc. So the immediate problem that comes in our eyes is that, okay, first, they completely miss any reference to biodiversity loss, but which could be even fine, but also they completely miss to consider any technologies or any areas of interest which cannot be strictly related to something, to a green label, because it relates, those classification relates only to technologies which have been developed only to the specific purpose of being green. And so anything concerning energy, wastewater, transportation, but for instance, completely overlooking any technologies which is more general or was developed for other purpose, but could be very likely applied also to solve environmental issues. And one among the others, for instance, the artificial intelligence, which is a very broad technology, but it's typically used for the automatic sorting and to identify, for instance, which materials could be recycled or not. Or the drones, which is a very general technology, but it's very important for biodiversity. So from this, they need to find a new way to identify biodiversity-related patents, and which is the goal of this study, which we are currently doing. How did we overlook the problem of not having identified patents on biodiversity? We use machine learning classification algorithm on patent abstract, and our contribution is mostly methodological because we want to provide a way to classify any biodiversity patents, and also empirical because we are able to open the black box of the biodiversity patenting activity and say, okay, but what are those patents about? What is the current state of the art on patenting activities on biodiversity? Which are the strongest countries for now involved in biodiversity, but in patenting for biodiversity activity, etc. Now, before going deep diving into our study and our results, I don't know how much you are familiar with machine learning approach. So let me just give you a very brief overview about the machine learning. So basically, machine learning is a subset of the artificial intelligence technologies, and it's in a nutshell a statistical approach which enables to identify complex pattern among sparse data. What is the advantage machine learning algorithm compared, for instance, to other statistical model? The main advantage is that basically with the machine learning algorithm, we are able to let the data speak by themselves. So we do not want to fit a specific function or a specific equation, for instance, like a linear regression or whatever, but we let with very complex algorithmic steps we enable the algorithm to find a pattern among data. So the explanatory power is much more stronger compared to other statistical models. Overall, there are two main types of machine learning. There is the supervised learning and the unsupervised learning. Basically, with the supervised learning, we give some input data to our machine learning algorithm, and the output we can receive are of two types. A classification, so it's a categorical or a dummy variable, depends on our request, in which basically we ask to the machine learning algorithm to classify some piece of data based on previous information that we give. Or we can also use the machine learning algorithm to make a prediction. So as we would use a linear regression model. So given those input, could you please predict the output given this, and this? And then we have the unsupervised learning. The unsupervised learning, basically, we do not give any previous information to our machine learning model, but we let the machine learning algorithm, for instance, to classify some data according to the best pattern he finds. And for instance, the generative artificial intelligence models falls into the category of the unsupervised learning. Specifically, the approach that we use is the supervised learning for classification. But what does it mean? So, supervising a machine learning model, supervising to obtain a classification or regression means that we basically instruct the machine learning algorithm in how it should classify our data set. So normally the input data that we want to give to machine learning are labeled. So for instance, in this case, we say to our machine learning algorithm, okay, look, this is a cat, this is a dog, this is a dog, this is a cat. Now, given those data or other data that I'm giving to you, could you please find the pattern among the data that identify cats and dogs? And could you please classify the rest of the data set? While, just for a comparison, in the unsupervised learning, basically we give non-labeled data as input. We let the machine learning algorithm to understand the pattern and to generate outputs based on what he thinks are the best pattern among data. Just to come back to our study. So basically we implemented the machine learning classification algorithm on patent abstract, so on textual data, to identify and to classify biodiversity related patents. We also have previous studies that made use of this novel approach to patent data for classifications. For instance, we have evidence about study on artificial intelligence, on to identify organizational innovations, emerging technology, or simply to clusterize patents. So basically, it's getting quite common to have this sort of novel approach to understand like huge amount of data, such as patents, and also to find patterns that could not be found with other statistical tools. What we do, so let's get into a little bit more in what we have done. So first, we have collected data to feed, our machine learning algorithm, and we collected, we retrieved the patent, all the patent granted at the European Patent Office. But we selected in order to have like a sample which would be intelligible, so understandable for these preliminary steps in which we are still doing a sort of exploration, of the methodology. We use some keywords concerning biodiversity to reduce the noise, and so a little bit to make a preliminary sort of the patents. And those keywords I did not report in here for a matter of space, but the keywords do not relate specifically to biodiversity, but more there are some keywords which have been selected by a previous study and which concern the sphere of biodiversity and biology. Second, we apply, and this is something that we personally have done as researchers. Second, we applied the text mining algorithm in order to pre-process the data, to normalize the format, to remove the stop words. And the lemmatization. Lemmatization is still a text analysis approach which serve to reduce the word to their lemma, or basically their root. And this is very important for computational reasons, so to let the algorithm to be more precise in understanding the word. As fourth step, we constructed the training data set. So basically, this is the steps. These are very important steps in which basically we instructed our machine learning algorithm on what does a patent about biodiversity look like, and how does a patent not related to biodiversity look like. And this is very important steps because the machine learning algorithm learn from our training data set and classify the rest of the data set based on how we instruct it. So once we constructed our training data set, we were able to apply several machine learning models and to choose the machine learning algorithm which which show the best accuracy. Just an example, a patent which was labeled as 1, so related to biodiversity, it's, for instance, the present disclosure relates to a method of directing the evolution of an organism by modifying the mutation rate of an organism. The increase in genetic diversity is used to facilitate the selection of a desired hereditary traits in an organism, etc., etc. Okay, so for what concerns the machine learning models implementation, we implemented several models. The random forest, which is one of the most famous, I would say, the linear SVC neural networks, GBM naive Bayes, and at the end we picked the one that showed the best accuracy. In this case, most of them are around very close to 0.8, but the one with the highest accuracy was the naive Bayes rose. Yeah. Yeah, done, almost done. So out of an initial data set of 17,088 patent abstracts, we created a training data set of 400 patent abstracts. We applied the machine learning model, and our results show that out of our initial data set, only 20% of patents, so 260, concerned biodiversity. A very preliminary analysis, non-descriptive statistics about the identified biodiversity patents show that for what concerns applicants and owners, the US still lead the position, even in European Patent Office data, followed by Germany and Netherlands. While for what concerns the IPC classes, so the category, I would say the theme related to our patents, we saw that the highest number of patents concern the chemical sphere, while followed by the patents on agriculture and specifically the development of new plants. And also a very preliminary analysis of the content on the patents on biodiversity showed that there are three main clusters of patents. Patents concerning molecular and sequence-based innovation, plant genetic engineering and trait improvement, and microbial and biocontrol methods. So these preliminary results tell us what are the areas which are mostly covered by biodiversity patents, and which could serve also to like a sort of preliminary evidence on which other areas maybe are currently underrated, and what areas could be and should be a little bit boosted, pushed. Next step, because as I told you, we are at a very preliminary phase, so we are still trying to fine-tuning the methodology. The next steps are exploring the content of biodiversity-related patent with BERT model for topic modeling. They are advanced machine learning approach which enable to better understand the meaning on text and to perform very powerful classifications. And second, also to make co-occurrence analysis using advanced textual network approach, for instance, to understand whether there are connections between technologies mentioned in the patent. Of course, conducting additional patent analysis of bibliometric data. And also another potential idea for the future is to integrate the data set with other country-level data and to observe whether there are some patterns between the biodiversity activity among different countries. And lastly, for sure, we will replicate also the analysis on USPTO data, which are even from a numerical perspective broader than the data on European Patent Office. But for now, we decided to keep the sample not so large in order to be more able to have a control, over the results and over the analysis. But for sure, this is we are in the very fine-tuning phase, so there is a lot to do, and we've done with the presentation, and I hope to receive feedbacks, comments, anything which is not clear, because it's the first time also we are presenting and we are sharing, so we are I wasn't sure that everything was so clear, because it's not that even that easy to communicate. So I hope you have any ideas how to improve it and what to do to improve it as well. Thank you.
Thank you very much. and Fabrizio. That is very, very exciting. If for the audience, if you want to put questions in the chat, you can do that, but you can also raise your hand. But maybe before we go over to our audience, I'm going to ask the two discussants to speak, unless there's any kind of very burning question of clarification for Viviana before we do that. No, online room looks good. In-person room looks good. Daniela, would you take the stage first? Yeah, please.
Well, it's okay. Thank you very much. Let me say that my first reaction to this paper is a reaction of envy and admiration. Envy and admiration because as somebody who has worked quite a lot on patent statistics for a while, I mean, I appreciate that now there are a number of techniques which are able to squeeze from patent documents much more information than my generation used to squeeze, and to get very detailed information and then into this universe of patents that we used very much for the very simple reason that is public available information, and therefore there is no comparison with other sources, and you manage to squeeze much more information that we have been able to do. That's the general context. And I think this is even more important because when we move to what in the literature has been named general purpose technologies, becomes very difficult to understand what we are talking about. For the very simple reason that often the technology is very far away from what we expect. And this is even more important with one of the two so-called twin transitions, because while in the case of the digital transition, microelectronics and so on, it's quite clear what we are talking about, in the sense we are speaking about companies, mostly companies, trying to improve their products by moving into a competitive market and fighting also through patents as a competitive asset. In the case of the green transition, things are much more blurred. Why? Because often very simple social activities, such as the collection of rubbish, can contribute to the green transition, and therefore the technologies that can be applied to foster the green transition are much more wider than that. So what we are talking about, where are the sources of technologies? We don't really know. Might be mechanics, might be electronics, might be artificial intelligence, might be chemistry. So where are the sources of knowledge which will allow this sort of things? And therefore, the methodology that you are applied is very helpful in order to know more about that. So, my critical remarks. One critical remark is, of course, that we need always to be careful, and that's a remark to everybody using patents, about the lamp and the key. You know, the famous story, why we are looking, the drunk man looking for the keys under the lamp, and says, the policeman asks, why are you looking for your keys here? Have you lost the keys here? No, I haven't lost the keys here, but here there is a light. You know, and therefore, to what extent are really patents the good indicator to show these sort of things? For example, for all the variety of innovation or changes which are not associated to patents, since this is also mostly driven by the public sector, we wonder to what extent, for example, this is associated to bibliometric indicators. And for example, when you mention as next steps the use of bibliometric data for patents, I wonder to what extent you are trying to establish the connection between the two things, or on the other hand, you are trying to establish to explore another, even wider universe, which is the universe of public sources, scientific articles, or whatever it is. The second is that at the end, of course, nobody is interested to be a patent maximizer. patents are useful, but what's really important is to see what's happening in reality. So, and that will move out of the size of the databases that you are using in order to know what's happening in the real world. To what extent these patents are actually leading to something which can be associated to the diffusion of practices, the diffusion of innovation, new products, something commercial, or something which is associated to what the public sector can do about that. I will finish here by saying that, of course, these sources of information will be very important for two important communities. One is the public policy. The public is, not any longer in the United States, less in Europe, if we look, for example, at the next framework program. But still, there was a major commitment to finance the green transition, including biodiversity. What does it mean? And therefore, these sources of information are very important to know where the money should be put. Should be put in specific area of the chemical sector? Should be put in other areas? We don't really know, because everything can be associated to that. So at least this, and I urge you to be more explicit about that, in order to say, we are trying to provide information for policy analysis and policymakers in order to know what they actually need to do in order to obtain the level they would like to move. And the second is, of course, business strategy. But business strategy will require another analysis, another find. Companies are investing here. So far, you haven't told anything to us about who are these companies. And that, again, this is one crucial information provided by patents. We know not only what are the innovations, but we know who are the innovators. And that, of course, makes a fundamental difference. Fundamental difference because you might get some surprises, and often perhaps you will move and you will discover that the companies which are providing these sort of things are totally different. And information which is also useful for business strategies, because they will have some information in order to know where to move in and if they are prepared to move out. Last, very short comment, of course, here, your analysis will help very much in order to understand what is proximity. The proximity can be understood at the national level, at the regional level, and can be understood also at the company level. To what extent we know, thanks to your data, who are the economic subjects which are equipped to jump into these new sectors. And that, of course, in an evolving society where technologies are changing, that also becomes quite an important piece of information. Thank you very much for your work. We look forward to get the third rate.
Thank you, Daniele. Do you want to address Daniele's question straight away? I think there are 4 points. If you can, but not 5 minutes.
Really quickly?
Yeah,
or maybe I...
Well, I'm just pardon?
Or maybe I can wait also for...
Are you happy to?
Absolutely.
Super. Then I hand over.
I shall say, Brian, very interesting material. In grand chapters, which is really important for the planet. It's also really important going down different levels to the individuals, because we're all affected now. God knows what's in the toothpaste and what's in the food that we're eating, because there are all sorts of legacies from previous generations of industry and current things that are going to change our lives. We might all grow an extra arm, who knows? So it's really important that your work is feeding into understanding what the issues are and what the practical activities can be done to ameliorate some of the dangers. But you also mentioned the economic relevance of this topic, and that might not be the same. I think there's a tension between making money out of the patents and business to ameliorate some of these, but they might in the long term be addressing the right policies. And I think Daniele was alluding that is what we actually need to do, and how to stop the negative aspects of this, that if governments put money to stimulating industry to solve some of these problems, they might also be stimulating some of the wrong things. And I think that's a very difficult balance for politicians, because we all saw during COVID, they shoved money at the problem, and there are all sorts of ways in which money was wasted and diverted to the wrong causes. So I think the political economic issues are really very important. And just on the technical aspect, I was struck by the distinction between the green policies and the pervasive policies. I'd like a bit more about the balance of those.
Good.
Because
Quoting those care statements.
Joy, fun.
But we're getting there.
Have you tried, out of just sheer interest, putting it into Copilot or something like that and go?
Well done.
And so just the balance of those. I didn't quite get to grips with how important the pervasive ones were compared to the green ones in monetary terms, and also in impact terms, and whether they are mutually exclusive and whether there's any spillovers between them, and whether the data will capture those. But I think I'll stop at this, but I really enjoyed it, and I think it's a fascinating topic, so thank you.
Thank you so much, Helen and Daniela, for the comments. Fabrizio and Viviana. Viviana,
Thank you, Professor, for the feedback, especially because with Professor Archibudi, we had previously chance to to talk about this. So I know his point, and he has raised very important things. But yeah, I mean, I know his view about it. Professor, thank you also for your comment. And concerning the very last one, so the difference between pervasive and green. Indeed, maybe I was not clear enough, because it's not an issue, absolutely not an issue of balancing both of them, absolutely not. It's more the issue of thinking about technologies relevant to address environmental, climate change, biodiversity challenge, which are specifically those technologies which can enable, for instance, to save energy, to not pollute the water, to not pollute the air. So a very narrow, I would say, areas of technologies, while overlooking technologies which have not developed to be green with a specific green label, green purpose, but that they could be very useful to pursue environmental or to address environmental challenge. For instance, as I mentioned, the drones, which are absolutely not being developed for green purpose, but they are very important to collect data and to monitor, for instance, the state of the soil, or the artificial intelligence technologies to automate the recycling of some materials, for instance, in the textile, or also their technology. So our point was that also policies for green technologies are too much focused on specific green technologies, which are energy, transportation, pollution, overlooking others. So maybe there is the need to understand, okay, but what are those technologies which are pervasive, general, not specifically green, but could be very helpful in being green. And second, for what concerns the tension between economic activity and environment, it's absolutely true. No one actually wants to deep dive into it, because it's like an uncomfortable, absolutely uncomfortable topic, because most of the time being green means also having higher costs. So it's still not, we are still, I personally believe in, even though I'm very junior researcher, but I think that we are still very far from having a balanced green purpose and also making money out of it. But I mean, there's still a lot to do, and I'm really not able to answer with this study to this question, unfortunately, for now. But yeah, I don't know if Fabrizio wants to add anything.
No, just we would like to provide useful insight for policy. I think that we have to put together the several tasks that we are now development. So also all the policy concerning the public procurement for innovation, together with the patent analysis, if we link together all the result, I think that we can provide useful information for policymakers. We have to put together all these results that we are obtaining.
Thank you very much, both. I see we have 2 questions from the audience. Are there questions in the room as well? I would like to take Slavo. Thank you very much for joining us. If you come in first, please.
Thank you very much. Sorry, I was not able to attend today, although I'm 500 meters from you, not far from here. So I have 3 issues. First one is first very stimulating discussion and paper. I couldn't understand how did you distinguish between biodiversity related patents versus green patents, because I understand the way I see it is biodiversity is a kind of subfield maybe of green patents. So what were the criteria? How did you differentiate that? Second question is related to this distinction between general purpose technologies and green technologies. I refer to, there is a paper by Carlotta and Rasmus Lema, and the argument, at least from Carlotta, whom I know very well, is that the green technologies are not general purpose technologies. They're diverse. You cannot talk about any kind of techno-economic paradigm in that respect, some kind of clear technological trajectory. What is your conclusion regarding that relationship after or based on your work? That's because you are the one who kind of has a hands-on understanding of that. And the third question is, you're using machine learning, and I want to link to what was said before. You used machine learning for patents, but of course, there are all limitations of patents. There is also issues which come after the patents, which is the issue of scaling up. Have you thought, or if I was your funder, I would push you to use machine learning also for non-patent areas and for scaling up issues, for something which goes after the patent, because I don't see the reason why machine learning couldn't be used for that. Of course, it's much less structured type of data, but it's actually the only methodology which can get into the area which are not basically tractable in any other methodology. Thank you.
Thank you. Maybe should I?
You could. I've changed the camera, so you might be visible now.
Okay.
If you want.
Okay. Thank you very much.
Face me. Face camera.
Okay. Thank you very much for the questions. So starting from the first one, which is very good question. So how do we distinguish between biodiversity and biodiversity patents? So actually, could I open again the presentation very quickly? I don't know if it's still here, because I have an additional slide at the end, which I kept for this one. Okay. So basically, in order to be able to understand, but what is biodiversity about, and how do we, thank you, and how can we distinguish by a patent about biodiversity? Slide is coming. We had a focus group with some researchers which work with me and Fabrizio in this National Biodiversity Future Center. So basically, which is the global framework in which this study it's embedded. So basically, this National Biodiversity Future Center collects many researchers, but either in the economic area, such as myself, Fabrizio, or Andrea Filippetti, or our other co-authors, Antonio Zenilli and others. But mostly it includes people coming, researchers coming from specific biodiversity related areas. And so we had a sort of very long seminars in which we interviewed those researchers. We had some, we were able to collect and to share some information and to understand also what are the main biodiversity areas in which technologies could be relevant, and we distinguished several biodiversity areas, and we identified and we labeled, okay, this is a biodiversity patent if was if it fell within one of those areas, okay? And so our results, our training model, our training data set was validated by, if I recall well, 3 different scientists. So basically you say, okay, this is our training data set. Does it sound good for you? Because at this level, there is also the need of a technical expertise, because we are not that into biodiversity, even though after talking a lot with different researchers, we are now like having a sort of ideas, but still we had our training data set validated. I don't know if I answered to your question. And second, for what concern the issues, the problem between general purpose technologies and green technologies. So basically, what I mean, our conclusion is that maybe we need to enlarge a little bit the label for green technologies, also for those technologies which have not identified of being green. It's not a problem per se of like having such a distinction, but it's basically we missed, for instance, using technological indicators for green technology means that we are ignoring, we are overlooking important technologies which are not included. Oh, I have to look at there, sorry. We are missing technologies which are not included that could be very relevant. And this in order, for instance, to assess countries' technological advantage or companies' technological advantage could be very, very underestimating, I would say. I don't know if I properly get your questions. Otherwise, please just clarify it. While for the third question, so why machine learning for patents? Yeah, indeed, machine learning algorithm, once you have a training data set, can be applied to any textual data. We choose to use patent data because they are very, it's for the amount of patents available that we have, because the machine learning algorithm works very well with a very large, very broad data set, with the so-called big data. So we need a very massive set of information to apply those machine learning algorithms. For sure, we could apply to non-patent materials in order to, for instance, to investigate the scalability of the project, but I've currently no idea of which other documents or texts I could use. So if you would have any suggestion on which textual data to use, we would be very, very happy to get this idea or any others which could improve the works. I hope I answered your question, and I hope I also got the point, but really thank you very much for the interest.
Thank you, Slavos, and thank you, Viviana. We have a question from Grazia, please.
Thank you very much. I find the paper very interesting and your research really very, very interesting. I go back to what Daniele was saying about throwing some doubts about patents data. And essentially with the patents, some of them lead to a lot of investment in whatever field they are. Some lead to very little investment. And in some cases, we might even have a case that the existence of the patent prevents the spreading of investment throughout. Now, I think really your research would actually improve tremendously the usefulness of it if you could pair it to investment, to what happens in the real world once a patent has been allocated. And even if your sample will probably diminish considerably, but at least you will have some idea what goes on. Is there a possibility of you moving in that direction?
Thank you very much, Professor, for the feedbacks. It could be very interesting to link the data also with investment. So basically, if I can find a pattern among your comments, is that okay, patents are nice, we like patents, but in the real world, what's up? So I think that we could, even though having data about, especially at the company level, so at micro level, having data about R&D investment most of the times could be tough, and most of the time also the R&D investment data are quite, blurred, so we never know how good they are as data. But it could be a very interesting future direction. Once having an idea of how to solve this issue of investment data could be very interesting, and also much more concrete and linked to the reality, because patents activity, it's one thing, but in real world, so yes, from my side, yes. I don't know if Fabrizio, but yeah.
At the moment we have been focused just on the methodological approach, so it is very, very interesting to extend this.
Exactly. Any other suggestion how on what to do next? It's very very welcome, because yes, we are still really refining the methodology. Thank you, Professor. Thanks.
Thank you, Grazia, and thank you, Viviana. We have time for one more question. Thanos.
Hi. Thank you very much. Interesting topic indeed. I use machine learning to analyze policy documents, like around 2,000 policy documents, and back then when I was at University of Frankfurt. So what we observed is machine learning can distinguish false positives sometimes. So basically, you may have keyword like biodiversity in the abstract, but the patent is not about biodiversity. It could be something else. So perhaps I think that you might need to intervene manually. And I think you don't have many abstracts. It's 350 abstracts, right? So which is possible. I think won't take you long to do that. Yeah. So that's more like a methodological suggestion. Having two comments. The first comment is about the consequences of biodiversity patents, because you mentioned AI, that they're using AI. Some of the patents include AI, but what we know from AI is the negative effect it has on the environment. So AI companies are buying nuclear farms, and they're using a lot of nuclear energy to basically provide the energy for the service. At the same time, they're taking the supply of water from the local communities because they need to cool down the service. So I just feel like you may have to take that sort of more balanced perspective that biotech or biodiversity patents may not be that positive after all, because of the existing infrastructure we have. We're locked into a system where, whatever we do, it harms the environment. So the question is minimal harm, but still, it's something that we need to consider. So the negative consequence of that. And the last comment is sort of related to the previous one. I think it's Fabrizio who conceptualized biodiversity as an economic asset. Yet we've seen that it's chemical firms and agricultural firms that patent biodiversity patents. So the same firms that polluted the environment for so long, the same firms that they brought us into this mess, are the ones now that they patent it. So why should we rely on those players? That's my question. So, and why those players didn't see the environment as an asset, as an economic asset, and why they are forced to see it now, and whether should we rely on them?
Thank you very much, Thanos, for the. I should start for me. So for what concerns the methodological things of having false positive, I absolutely agree. And in fact, we tested many different machine learning models before having personally trained a data set. We actually relied on a pre-trained data set available from another university, which was the Biodiversity model, which is a very huge pre-trained model, but it didn't work at all. It included very many false positives, so we overlooked it. We manually coded it, but once we obtained the results, and this is the reason why we started from having a quite small data set, because we wanted to check the classification. And I can say that after the classification, we checked a sample, not the whole data set, but we observed very good accuracy of the classification. So I can say that after a long work of trying refining the training, setting, applying the machine learning, and then refine the training data set, we are at the good level. That's why we want to further refine it before applying it to a much bigger sample, for instance, the USPTO data, which are more than 8,000 patents, if I recall well, or really like very much important the database, much larger data sets, sorry. For what concern your the second point about artificial intelligence, I'm not sure I got well your point, but maybe, or maybe because it was my explanation of the presentation, but we did not consider any artificial intelligence related patent. Mine was just an example at the beginning about that some technologies could have other purpose than what they have been meant for, apart from the fact that, of course, they can harm the environment, but we absolutely, personally, we have not included them in the analysis. I don't know if this was the question, but yes, overall, absolutely, we need to consider then even general purpose technology can be good can be useful for the environment, can be also harmful. Absolutely, there is very need to consider the both. For what concerns the third point about the chemical company and who is actually patenting, indeed, and this is very connected to Professor Archibugi, Professor Archibugi comments, or Ellen, but who is patenting? Yeah. So it's totally true. We are at this level. We are still not yet looked at. Okay, what are the companies? What do the company do? But it's very interesting and next step. I will do it like this afternoon. I think now it's true. I'm really curious to know. Okay, US, German, but who? In chemicals. So unfortunately, I cannot answer to you now, but I will do in the next hours, I guess. Thank you very much. Fabrizio.
Thank you so much. We've reached we're on time. We can continue the discussions in the room, but I think we should formally close the session now.
Yes, well, thank you very much. It's been a pleasure to see you again, and thank you everybody for joining us online. Thank you.
Thank you so much.
Thanks.
Thank you. So a present for the speaker.
Thank you.
But thank you.
Yeah. Thank you.
Thank you. Thank you very much.
Thank you.
Yes, you're welcome to stay, but Marion is now leading us in yet another venue.